Hello everyone, I'm just going to take you through a quick question from a Step 1 paper, 2007, question 5. I picked this one purely because it's the start of the year and I'm going to try and get some of the year 12s who've just started like A-level maths or further maths into some of these like tricky problems, which they're really good for testing your ability to draw a decent diagram, which is such an unappreciated skill, especially if you've got a 3D diagram. Now, I'm actually really happy with the way this is going. I was actually anticipating that going way worse than it actually did. That's serviceable. I'm drawing an octahedron here, but an octahedron is basically like a pyramid on the top and a pyramid on the bottom. It's octahedron. I think of the hydra, like hedron is like Greek for heads, basically, or faces. That's what it is here. So a polyhedron just means many faces. If it's an octahedron, it's got 8 faces. So I'm going to try and draw exactly the same thing on the bottom, and this is normally where it starts to go wrong. Oh, it's so awkward. So making a little bit deformed over there. Hopefully it will be a serviceable diagram, and it does, it really helps the more kind of close it is to it, especially when we're doing something like this, because what they want to do, they're asking us, it's an octahedron, show the angle between any two faces is arc cos of third. Now, if you've never met arc cos before, please don't be freaked out by it. They just mean inverse cos of minus a third. I've got to show that like the angle between any two faces is inverse cos of minus a third. That's not, the inverse cos of minus a third bit is not the difficult bit. They're basically saying find the angle between the two faces. Yeah, that's what they're saying. So that's what we should do. Now, I don't know if you're familiar. I hope you are with the standard way that maths teachers will prove that sine 60 and sine 30 is sine 30 is a half, sine 60 is root 3 over 2. But the standard way is you do a little triangle like this, equilateral, and you make all the sides 2. So I immediately thought, well, it would be nice if all these equilateral triangles were sides 2. So let's give it, it just makes it less of a headache slightly in terms of figuring things out. Now, what is the angle between the two faces? Well, I guess if we were to take like a lovely perpendicular dot right down the middle of this, in fact, let me do it in a different colour. And also take a lovely little perpendicular, that one, yeah? That will give us the angle between any of the two faces, yeah? That's what we need. We need basically two lines which are, lying basically in the same plane, perpendicular to each other, to like find the angle between those two planes. This is a subtle point as well. People find this difficult, understanding where the angle between two planes is, how you draw this triangle, but you want to draw it like that, yeah? And then you're going to get the angle between that plane. Think this isn't just a triangle, this is a plane, you want to think of a plane as extending it in every direction, but with the same slope, essentially, that's what's fixed about a plane, the slope here. And so, yeah, the angle between those two planes, I hope you can see it's going to be this angle here, yeah? So what do we need to find? We need to find the length of that side, which will obviously naturally be exactly the same as the length of that side, because we're dealing with an isosceles triangle here, because these are all regular shapes. They're equilateral triangles down here and down here, so they should have exactly the same length when you take the perpendicular height, and that's all it is, perpendicular height. So let's try and work it out. Now, we said every side of these equilateral triangles is 2, so that means that like what I'm dealing with here, and maybe another colour change would be useful here, what I'm dealing with here, I think we know some of those sides, yeah? So let's just draw a blue triangle here. And let's say, well, that side is 1, because all of these are equilateral triangles side 2, and it's just exactly half of that, so that's 1. That side must be 2, and therefore this side is going to be 2 squared minus 1 squared root 3, yeah? So I know that side is root 3. Similarly down here, that side, which forms another exactly identical, congruent, as the phrase goes, congruent triangle down here, and so that's also root 3 for exactly the same reasons. Root 3. Okay, cool. So on our original red triangle, we've now got two other sides. Let's draw that red triangle out somewhere separately as well, because that's the one we really need. What we really need is this angle in here. Yeah, that's the angle they're talking about, the angle between the two faces. Now, let's call it theta. You know, that's right. Thin pen. Theta. Yeah, we've discovered that's root 3, and that's root 3. Yeah, so we're getting there. We just need this length. Then we can find the angle. We'll talk about how we'll do that in a second. I hope you already got there before me, and you know it's cosine rule. But if I get that length, then I can find the angle and hopefully show it equals that. So what's that length? Well, that's that's different. I'm going to have to draw a different triangle now. Let's use green. Let's try this triangle. If I want, what am I looking for again? I'm looking for that distance from there to there. Okay, there's various ways of doing this. I already know. That's the thing with diagrams. Oh, tricky on this question. There's no denying it. It's hard to do it. I know you've probably not got colouring pens as well, so it's really hard to do. I feel your pain. I was not brilliant at art myself, by any means. Okay, I'm trying to find this side, and then I'll just double it. Yeah. Now I already know that that length is a root 3, and this length must be a 1. Yeah, because it's half of 2. It's halfway across. From there to there should be the same distance as that, because this is a square. We're taking the middle of both. It's obviously that side is parallel to this edge and this edge, and so that's going to be, I hope I've made that clear, root 3 here and 1 down here. So if I can just draw a green triangle out here, what we've got is root 3, we've got 1, and so we can work out that is that squared minus that squared. That's going to be a root 2, isn't it? That squared plus that squared is that squared, yeah. And so we've now discovered that that's root 2, and so this side will be 2 of those root 2s over in root 3. Okay, perfect. Okay, now we can show the result that we need to show. Cos theta is going to be equal to, well, we're going to use, that's a cosine problem, isn't it? B squared plus C squared minus A squared, so it's going to be root 3 squared plus root 3 squared minus 2 root 2 squared over 2bc, so 2 times root 3 times root 3. Okay, what do we get with this then? We get 3 plus 3 minus 8. 2 squared is 4 times root 2 times root 2. So divide by 2, so that's 8. Okay, on the bottom we're going to have 6. Let's just root 3 times root 3 times, which is 3 times 2. And so we end up with minus, what have we got there? Minus 2 over 6, and so theta, theta is inverse cos of minus a third, just as they told me it would be. So things are going well so far, but let's not get overconfident, because the worst part of this question is definitely the second bit, where now let's see how well this goes. I've got to draw a cube inscribed essentially inside my octahedron, such that it hits the median of every face, yeah? And what I mean by that is it hits the middle of an equilateral triangle. Every equilateral triangle has got a middle, and it's where you draw this lovely, I was a big fan of Back to the Future when I was younger, but this looks like the flux capacitor to me in that film. But anyway, that's going to be cut in half, and so that will be just 30 degrees. Down here, if we can just edit that and make that just that bit's 30, and so you can work out lots of things about that, because every single cube is going to be hitting these. So this is going back now. This is where my original confidence at how well the diagram was going is suddenly going to be turned up. Let me draw the octahedron again first, and hopefully that won't go too badly. Not too bad, it's sort of serviceable. I mean, it's tougher diagrams, but definitely on these kind of questions, a good diagram will help not to mislead you, if you see what I mean. Okay, so let's change the colour again. Okay, we need the 4 median sides of these equilateral triangles. We're going to fit a cube basically. This is on this side, this is on this tricky to also that's on that side, that's on this side, that's on this side, that's on that side, yeah. Now, let's draw the cube with a really thin pen. We're going to have a cube which fits inside there. Oh, this is so challenging to draw. Feel your pain. But the better you get that, the easier it is. Okay, what are these all doing? They're well, firstly, we want to work out the volume of the octahedron to the volume of the cube inside it, yeah? And we can, if you want some easy marks here, work out the volume of the octahedron. Remember, we said it was, because if we're doing a ratio, it doesn't matter what side length we pick, just as long as they're reflected with the cube, which they will be. And so if we say that's length 2, how do you work out the volume of an octahedron? Well, any pointy shape in maths which tapers to the top, whether it's a tetrahedron or whether it's a cone, you always do the same thing. You do a third times the base area times the perpendicular height every single time. And so an octahedron you can think of as 2 pyramids, square-based pyramids. And so we can work out the volume of the octahedron just by doing a third times by base area times by perp height times by 2, because there's 2 pyramids. Okay, so the volume of the octahedron is going to be 2/3 times by the base. Well, that's just 4, isn't it? It's 2 by 2, it's a square. It's 4. And so times by the perp height. Well, didn't we just work that out over here? The perp height of one of these is going to be, can we still read it? I think it's √2, isn't it? Because when we doubled it, it was 2√2. So I think that's supposed to say √2 under all that pen. So that's √2 times by 2. Yeah. Okay, what have we got here for the volume of the octahedron? We've ended up with 2 times 4, 8, times 2 is 16 √2 over 3. Oh, sorry, no, I times by 2 twice, haven't I? Yeah, I was thinking, I was just glancing at my notes and it's like I had 8 √2 over 3. I've already times the 2 over there. So 8 √2 over 3. Cool. Okay, let's work out now the volume of the cube. Now, to work out the volume of the cube is fine if you can find one side length. So we just need to find the distance between that median and that median. Yeah. Now that's not too bad actually, because if you think about this, and this is where the diagram gets tricky. We've got another isosceles triangle like that in there with that cube, and remember as well that we already know that angle in there, it's the angle between 2 faces, it's arc cos of -1/3, or inverse cos -1/3. So if I just notate that, let's draw this red triangle out here. Well, let's draw it red as well, so it looks a little bit more like this is what I'm trying to get at. I've got a red triangle in here, yeah? This side is the side I want. I know that angle, think of it like that, it's theta, where cos theta is -1/3. Yeah, and that's what theta is down there. Okay, we just need that distance, and we've got this, remember, and so we can find the side of the cube. Yeah, we can find that length. And that's what we really need to solve this problem. Now, we don't already know that. We need to think about basically an equilateral triangle. What we need is, because it's hitting at the median right in the center of it, a natural way of describing the center of an equilateral triangle, if you like, we need this distance. Yeah. Well, we know that is going to be at an angle of 30 degrees because it's going to be bisecting the angle. You get a lovely, it's a kind of, there's mathematical names for that shape, but I always think of it as a flux capacitor from Back to the Future. Okay, so what have we got? We've got that side length 1, because remember these are all 2 by 2 by 2 equilateral triangles. So what is this? Well, do you know that tan 30, for example, this is one way of doing it, is equal to 1 over √3? Because if you know that, then there's, and you're looking, and remember that equals the opposite. Let's call this x. So 1 over √3 because that's tan 30. Well, that's equal to opposite x divided by adjacent 1. So x is 1 over root 3. Great, we've got that length, yeah? We've now got this as 1 over root 3. Both sides as well because of the symmetry. And so we can now work out this side length, yeah? Let's call it a, yeah? A squared equals b squared plus c squared minus 2bc equals a. That's all I'm using here. So a squared is going to be a third plus a third minus 2 thirds times by minus a third. Oh, that's interesting. So we're going to be adding that last term. And so what is a squared? A squared is 2 thirds plus 2 ninths. 2 thirds is 6 ninths, so that's 8 ninths. And so if you like, a is 2 root 2 over 3. Cool. Okay, all we need to do now is work out the volume of the cube. That's going to be equal to 2 root 2 over 3 cubed. And so you're going to have, what have we got here? 8 times by 2 root 2, so that's 16 root 2 over 27. Yeah? So the ratios are 8 root 2 over 3 to 16 root 2 over 27. I'm going to do big to small because I think that's what I asked for in the question. And then we're just going to simplify. So times that over there, that's really 72 root 2 to 16 root 2. Why haven't I cancelled the root 2's yet? It's crazy. Divide both of these by 8, you'll get 2 there and 9 there. So the ratio is 9 to 2. Yeah, there we go. I mean, what's hard about that question? Drawing the diagram. It really is. I was tempted to use GeoGebra for this video. It would have made it easier for you to see what I was getting at, definitely, but you're not going to have the benefit of that in the exam, and it's like, try and draw good diagrams. To be honest, you know, use colouring pens if you like, but yeah, maybe I was cheating there a little bit using the colouring pens. I did it before I did the video though, and I promise you I did it with some, you know, just like really awful diagrams, but it just about worked. Okay, yeah, keep up the hard work and bye.